Hello and welcome to another surging session. How about that? How about that? Hello everyone. Welcome. Hello Gaduk, hello Draco0x, Crochet, Lost Algorithm, hello. So today I decided to make a small break from the text editor development, right? So because we've been developing text editor for almost a week already. I think it was like basically a week of development of this text editor. So if I work really long on the same project, I actually get sick of it. So I decided to make a small break and do something else. So the thing I wanted to do today, I have a build system, my custom build system called No Build. You can find it in here. It's actually a very interesting build system. It's a header-only library for writing build recipes in C. So the main idea is that you should not need to anything but a C compiler to build a C project. No make, no CMake, no shell, no CMD, no PowerShell, etc. Only C compiler. So with the C compiler, you bootstrap your build system and then you use the build system to build everything else. That's the sort of like a premise of this build system. So for more information, whether it's like a good idea or whether it's applicable for a project, read more about like that in a README. I'm gonna also put this entire thing in the description for people who's watching on YouTube, and for those who's watching on Twitch, I do upload these VODs on YouTube. You can find it in here. Source code, right? So we're gonna put it in here. So it's a pretty interesting build system. We can take a look at how it works essentially. So I'm gonna show the idea. So maybe I'm gonna create no build demo. Let's call it no build demo. And let's create a very simple program, something like hello world in C, right? And it's going to be stdlib. Then I'm going to return 0, and of course it would probably make sense to say hello world because it is in fact a hello world program. So so such a small program doesn't really require any build system, right? Because you can just build with a single compiler command, and there you go. Here you have your hello world, right? But I'm still gonna use this program as a means of demonstration because like I don't have anything better anyway. So the way you use it, all right? So you grab this header file, right? You grab this header file and you basically download it into your project, right? Then you need to write a build.c file, right? You write build.c file, you need to include no build.h and simply return 0. Okay, so this is an STB style header-only library. So that means there's somewhere an explanation in here. Right, so that means you'll have to put this macro in front of the include. If you don't know what the hell that means, read more about STB style header-only libraries. So the thing about them is that if you include them, by default, they don't include any implementations. You'll have to indicate that you want to include implementations by defining this specific macro. Right, so, and the reason why it is like that is so you have more control over where implementations are going, in which specifically translation unit they're going. So if you're going to put implementations in all of your possible translation units, you're going to have like collisions, like name collisions during the linkage, and this is basically a way to control where implementations are going. That's basically what it means. Read more about that in this document created by the main creator of STB libraries. And I'm going to put that in the description as well. Okay, so this is going to be description somewhere here. So this is a STB how-to. I'm going to put it in here. All right, and essentially now you can call external commands, right? You can call external commands. Let me see how we do that because I kind of forgot how to do that. I think you just use this CMD macro. Yeah, there we go. You use CMD macro. CMD cc o main main.c, and I guess that's basically it. And then first thing you do, you bootstrap your build system, right? So no build.c. There we go. The build system has been bootstrapped, and you run your build system, and your build system already builds your executable, right? So, and essentially writing builds in such a build system is equivalent of writing build system in a shell, essentially. For more information about this kind of style of builds, like just read more, read me. So everything people, people asked a lot of questions about this entire thing. I try to put as much information about this build system in readme as possible, so you have no other questions of what it's meant to do and what's the target audience and stuff like that. All right, anyway. So now, interesting thing about this stuff is that it's cross-platform. Yes, it is cross-platform. So essentially, you can do something like, if you are on Windows, right, you call cmd clxz main.c. Otherwise, if you're in a POSIX system, you call the POSIX compiler. Right, so, and that will work. So CMD has implementation for both POSIX systems and Windows system. Right, so it is relatively cross-platform. I do use this build system for my compiler infrastructure, which you can find in here. I actually streamed a lot of streams developing this entire thing. So it's basically its own virtual machine, its own assembly for the bytecode of the virtual machine, and the simple language that compiles to that virtual machine. It's a lot of interesting things, so I really recommend to check it out. Right, so so project where I use no build, right? So stb how to. There we go. And it's a relatively big project, and no build works relatively well for that project. We can take a look at how well it works there. And it builds on all of the major platforms. It builds on Linux, macOS, Windows, right? So, and it doesn't use anything but no build, and it has several sub projects that needs to be built as well, right? So, all right. No, and the way you do that, you just basically bootstrap the root no build, right? The root no build. So the root no build looks like this. What's interesting is that it knows all of the sub-projects, it iterates through all of the sub-projects, then goes into those sub-projects, builds their internal no builds, right? Each sub-project has its own no build thingy, and then runs them. So it sort of basically goes through all of the sub-projects and builds everything. So, and yeah. So that's basically what it's doing. It's our build system working right now. And it doesn't use anything, no CMake, no make files, no shell script, no anything. The entire project in C is built with the code written in C. That's kind of the point, right? On top of that, you can also run tests. So yeah, it's kind of, I don't know, I still don't know if it's a good idea or not. I'm still sort of experimenting with this idea. But here's the thing, this entire approach, even though it's interesting, it has one inconvenience. If you change your build recipe, you have to rebuild the executable, otherwise the recent changes won't be applied. So here's the following idea that I want to try to tackle on today's stream, right? So I've given you the whole context of what I'm doing right now, right? And what I'm trying to do right now, I want to implement a feature so the executable detects that the source code was modified, and it will try to rebuild itself accordingly, right? So essentially you already have like a bootstrapped system. It runs, it detects that .c was changed, and it will try to rebuild itself before actually running. That's what I want to try to implement, and I want to try to implement it in a cross-platform manner, meaning that it should work on both Linux and Windows. Right, on Windows it's a little bit more complicated, but first we're going to implement it for POSIX systems. Okay, so interestingly enough, the detection of whether something was modified is not a new idea. It existed before for quite some time already, I would say. I could demonstrate you probably, maybe with them. Yeah, it would be nice to actually have a more sophisticated program that does more things. For instance, we could have separate translation units, right? So let's actually do something like hello, right? So we're gonna have a separate function, and inside of that function, we're gonna put hello world, right? And in here, we're gonna be calling hello. There we go. And I also want to actually remove no build for now, right? I want to remove no build for now, and I want to introduce a make file, right? So in the make file, we're gonna just build this entire thing. main.c, right? So, and if I try to build it like that, it actually builds and everything is okay. All right, so let's actually try to move hello into a separate translation unit. So I'm gonna create a header file, hello. Hello.h, define and if, and we're going to have hello function, right? So this is the header, this is the definition, rather declaration, I'm sorry, it's a declaration. Then we're going to include the hello.h, right? And then the implementation is going to be moved into here. There we go. So, and here we're going to only include the header file, right? So now we have two separate translation units, and let's make a build that builds two separate translation units separately and then links them together, right? So let's do something like main. I don't know, yeah, it's going to be called main. Main depends on two files, main.o and hello.o. These are compiled translation units, right? And then we link them together like this. So to build main.o, we depend on main.c, and another interesting thing, main.c depends on hello.h, right? And then how we build all of that? We basically use the flag -c, which indicates that we don't want to build the final executable program, we just want to translate a single translation unit into an object file. And that will give us the necessary results. Right, I can even build these translation units separately in just a second. So I think it has to be something like main.o. Yeah, it's already built. It's actually tried to build everything, but I mean the compilation has failed because I didn't finish this thing yet. All right, so hello.o, hello.c, hello.h, hello.c. There we go. So, and we have some compilation errors in here. Just a second. Yeah, there we go. So I don't understand what is that. Probably because I have to include these things. Oh, there we go. All right. So as you can see, this entire thing, what does it do? It first builds one translation unit, then the second translation unit, and then it combines both of the translation units together. So it's like a three-step build, right? And the order is actually defined by target and dependency. So we have a target main, it depends on these two things. These two things depend on these things, and this thing depends on these things. And this is how we build the targets, right? So that sort of forms a dependency graph, right? This forms a dependency graph, and that's how Make knows how to modify things. Interestingly, if you try to rebuild it now when everything is built, it's not going to build anything. Right, it's not going to build anything because everything has been built. But look what's going to happen. I'm going to try to modify hello, and instead of hello world, I'm going to say hello chat. And I'm going to try to rebuild it. Look what happened. It rebuilt hello, but it didn't rebuild main. So it just reused already existing object file. Right, it knew what exactly I modified, and it rebuilt only the things that I modified. How did it do that? The way it did that is essentially it compared the time of last modified makefile and last modified target file. Right. So interestingly enough, so the current time is 21:31, right? And if I try to recompile it again, interestingly, it didn't do anything. Interestingly, it didn't do anything. Oh, I think I know how it happens. Look. Right, so the time of last modification of makefile is 21:31, right? But the time of last modification of main is 29. If I add any modifications in here, the last modification date is going to be 33, which is bigger than the time of the last modification of makefile. And that's precisely what makefile detects. Right, it will see that the last modification of the dependency is bigger than the last modification of this thing. Maybe it also actually compares the... Yeah, it could be actually comparing last modification of the target, not the dependencies. Oh, okay. Yeah, it's the last modification of dependencies, I see now. Yeah. So it's not comparing the makefiles. It's comparing actually dependency and the target. Right, so the modification of the dependency is less than the target, and that's why it will be rebuilt. So let's actually wait a little bit until maybe 35. Right now it's like 34, and I actually want to wait until 35 just to see what's gonna happen. Yeah, it basically compares inputs and outputs, right? So as you can see, I myself don't really understand fully how it works, but I roughly understand it's something based on the times, right? So since in the makefile it is specifically said that main.o depends on main.c, so it will compare probably the times of these two. Right, it will compare the times of these two. So as you can see, the time of modification of the target is bigger than the modification of the dependency, and if I try to rebuild, nothing is going to happen. Now, if I modify something yet again, the time of the dependency is bigger than the time of the target, and that's what will trigger modification. And what's interesting is that now they have the same time. Right, so it's based on time as far as I know. What if you manually change the target? Change in what sense? Update its time? It will probably break. We can try to do that. Sure. So I modify this thing. So this is the dependency. And then I want to modify this thing. Let's actually put some space at the end. Right, and if I try to rebuild, it actually... Oh, yeah, it didn't rebuild main.o. That's actually very interesting. So it is consistent. It didn't rebuild main.o, but since it detected that main.o is the dependency of main, the modification time of main.o was bigger than main, and that's why it rebuilt the main. You see what's going on here? So yeah, it actually based on time, and if you modify this thing directly, it will, yeah. It will actually not do anything. So we can add a little bit more garbage in here, right? And it will keep rebuilding main. But now look what's going to happen. I'm going to add more garbage in here. That will bump the time. And then I'm going to add more garbage in here as well. And because of that, everything is up to date. So yeah, you can trick makefiles by make system by modify the touch times. Oh yeah, you can also touch, yeah, of course, whatever, doesn't matter. It's all details, it doesn't matter. Okay, so basically what I was trying to explain, the approach, right, which we also may try to use with our system. So yeah, and in our case, right, so in our case, what we're going to do, right, so let's actually go back to hello world. Let's go back to hello world. Should have not removed no build, but I just didn't want to keep it in a folder because it will be very distracting for the people. Okay. So yeah, we need to make a no build. I'm gonna include no build.h, no build implementation. So return 0, cmd, cc, o, main.c. Okay. So, and if I do something like this, no build.c, no build. Yeah, there we go. So essentially what I want to do, I want to compare modification dates of no build.c and no build. Right, and if the modification date of no build.c is bigger than modification date of no build, I will try to rebuild myself and run the new modified version, new freshly rebuilt version. So that's what I want to try to do. But the first thing we need to do, we need to learn how to get the time of the file. Right, I do remember that we had a way to do that. Modified. I don't think we have a way to do that in our library. Okay, so I guess we'll have to implement it from scratch. So it's probably something like stat, right? So let me see. I don't remember. Maybe it's a stat, maybe it's not. We can always just Google it up. So there's a mode, idef. Yeah, so last access, last modification, last status check. Okay, so that's basically the thing. It's not really cross-platform, but for Windows we can implement that separately. We can probably implement that separately. All right. So let's go over. Let's try to do the following thing. So getting the path to the executable should be relatively straightforward, right? Because it is the first argument in argv, right? It is the first argument in argv. If I do something like this, right, and if I show argv.0, right, argv.0, it's going to be the path to the executable. Right, so let's do cco no build.c, right, and if I try to run this entire thing, yeah, so it's kind of the first value is printed by Emacs, because Emacs always first prints the command that you executed and only then starts the output. That's why it looks so weird, right? So maybe in reality what we want to do is just basically wrap it, maybe separate it by some sort of a line. So yeah, it would be a little bit better, if you know what I mean. Right, so something like that, and there we go. So here is the output, and you can clearly see this is the completely separate command. So we need to take the time of this file. But here's the second thing. How do we know the path to the source file itself? Well, we can actually bake it into the executable. There is a special macro in here called file, right? So, and if you try to do something like this, there you go. So we've gotten access to the executable that we're running and the source code from which it was actually built, right? So we have both of the things. So the only thing that is left in this particular situation, and by the way, I really want to mention that both of the ways are completely cross-platform. So this kind of way of getting executable and the source code of executable is going to work on both POSIX operating system like Linux and macOS and Windows, right? At least it should if you have a standard compliant compiler, right? So what's not going to be cross-platform is the way we're going to take the time, right? So in case of a POSIX, we are going to use the stat function, right? state2, stat2. We'll need to include that, no build.c, no build.c, and yeah, that's basically what we need to do in here. Okay, so this is going to be that. We have to provide the file path. So I'm just thinking, what's going to be the best way to do that? Maybe we're going to have a separate function in here. Get time, right? So it's going to have const char path name, right? Const char path name. We're going to move this entire thing in here. So here is the path name, and we're going to allocate the stat buffer on the stack. I'm going to also zero initialize this entire thing, and I'm going to give the pointer in here. And as far as I know, if it returns like a negative value, right? So what's the return in here? So yeah, on error it returns a -1. If this entire thing is less than 0, right, we're gonna instantly print f error, could not stat file because of this thing. So it's going to be path name and str error no, and then we're going to exit with 1. There we go. So we're going to indicate this as an error. All right, so to be able to do str error and error no, we'll have to probably also depend on such thing as std, I think string at least, and also error no, right? So str error is located in string for some reason, and error no is located in error no, if I remember correctly. I don't know why I remember this kind of things, but I do remember this kind of things. Okay, so stat, and what we need in here, in fact, is a field from this structure. So last modification, so I suppose it's going to be st empty, yes, that's what we need in here. So this is going to be stat buff, like this. And by the way, this should not be a pointer. This should not be a pointer. Okay, what I want you to do now, I want you to print modification date, right? So this is going to be modification, and then we're going to do get time, boom, and then get time, boom. There we go. If I try to recompile this entire thing, it's not compiling because I forgot to put std error in here, and also there's problem in here. Incompatible type, time spec but int. Okay, so time spec, oh, time spec apparently is not a number. I thought that time spec was going to be just an integer, which is the amount of seconds, but apparently it is not. It is not. Okay, so let's take a look at what the hell is that. Oh yeah, it used to be, oh, this is very interesting. Apparently it used to be amount of seconds, and then we replace it with a structure, but for backward compatibility there's this macros. This is very interesting. So you can just put e in here and you will get the thing. This is so cool. That's a very interesting way of keeping backward compatibility. I just put e in here and it will give me the right thing. Would you look at that? And this is the Unix timestamp, if I understand correctly, right? So basically the amount of seconds since 1970, right? Amount of seconds since 1970 Is that what it is, right? So is that what the Unix timestamp is? I think it is. I'm pretty sure it is. Yeah, epoch time. All right, so look at that. This is actually a very cool way of keeping backward compatibility. I really like that. So essentially these things are structures, but so you can access them as seconds. You have this macro that expand into try and access these seconds. This is actually pretty cool. I don't know, it's very hackish, but macros in C are always used like that actually. So for, you know, sort of like putting a hack in there for backward compatibility and whatnot. Error no, by the way, for instance, in majority of the systems, right, error no is a macro to a function call, which grabs the error no from thread local storage, right? Because you may have multi-threaded application, and for each thread there is its own copy of error no. But to make it appear like it's a single threaded, so they put it behind the function call, and for backward compatibility with existing code, that function call was wrapped into a macro, right? Usually, so there is some situations when error no is not a macro, but in majority of situations it is. And by the way, the reason I know that is because in Rust there is C bindings for Rust, and there's a huge pain in the ass of getting error no from there. Like, holy fucking shit. So it's like getting the value of error no, of C error no in Rust is an unsolved computer science problem worth of thousands of PhD theses. Seriously, like, holy fucking shit. It's really interesting. So if you try to find libc, yeah, I'm telling you, look, it's fucking insane. I tried to look into that, and it's fucking insanity. So if you take a look at the this thing, right, try to find error no. So libc is supposed to have error no somewhere, right? Error no. There is no error no in there, but there is something called error no location, which is precisely the function call I was talking about, and it's absolutely unsafe and stuff like that. But this is not it. This is not it. You may say that, okay, just, you know, just use this function call. But as far as I know, it is not supported on all of the platforms. It does not exist on all of the platforms. So there's something about Dragonfly BSD up until particular version, it doesn't have that function call in its standard libc library. So on top of like, yeah, so basically the reliance on this thing is completely inconsistent, right? Interestingly enough, they could have actually implemented a function that gets you the value error no of error no and sets the value of error no and basically abstracts away the entire problem with libc and stuff like that. But they don't want to do that because they want libc to be one-to-one correspondence to the C version of libc, and introducing some functions introduces new names that don't exist in libc, and because of that they don't want to do that. And you know what was the solution? You know what was the solution? They created a separate crate. So there is an absolutely separate crate called error no. Specifically for getting error no in libc. And depending on different platforms, they have like a bunch of there you go. Depending on different platforms, they call to different functions. There's __error, __error no, error no location for different libc functions, because it's impossible to put that to the standard libc crate, because, well, that breaks a lot of assumptions about libc. Holy fucking shit. Like, how much effort do you want to put into getting 8 bytes in the memory, into locating 8 bytes in the memory? I just don't understand. It's freaking 8 bytes in the memory. Like, how more complicated do you want to make it? I don't know. Maybe I'm just out of touch with the reality. Maybe I just don't understand anything. But it's just like the whole situation. I was trying to look into this situation, and the whole situation looks absolutely freaking ridiculous. It's just like I don't understand it. Maybe I am in fact out of touch. Maybe that's normal in software development. I don't know. I have an idea for my PhD dissertation. Oh boy, I'm sorry. And yeah, of course, Rust is not annoying. Rust is not annoying. It's a good language. You just have to get used to it. You just have to get used to it. More copium. You just have to get... It's inconvenient at first, but you have to get used to it. Oh, more copium. All right. So what I was doing, I think I wanted to make a cup of tea, by the way. All right, let's make a cup of tea. Let's make a small break, and I'm gonna make a cup of tea. Let's do the following thing. We can get the time of the source code, right? It's of the binary and the source code. So let's actually try to detect when we need to rebuild, right? So so let's do something like this: source path, right? So this is the source path, and it's going to be essentially file, and then binary path, and it's going to be argv. But the important thing about argv, right, is that we assume that there is at least one value in argv array. All right, so we're going to do assert argc greater than or equal or greater than 1, right? Or maybe it could be, I'm going to put 1 in here, whatever. So, and in here we can have something like source time, right? So this is going to be source time, get time, source path, right? And then we're going to have binary time, which is get time, binary path, right? So there we go. So the next thing we're going to do is if source time is greater than binary time, we're gonna print needs a rebuild, right? Needs a rebuild. Otherwise, up to date, right? There we go. So this is basically how we're gonna detect that. All right. So I'm gonna rebuild this entire thing, no build.c, and it does not compile because of that. And let me try to do that. And as you can see, everything is up to date. Everything is up to date. Nothing particularly special. But if I modify the source code, it needs a rebuild. That was easy. So we can at least detect that the program needs to be rebuilt, right? Just by looking at the time of the source code file and the binary file. So essentially, when it needs to be rebuilt, what we need to do, we just need to rebuild. Right, we can use the capabilities of no build itself to rebuild the thing. Essentially, we can try to do something like cco no build, and we're gonna try to rebuild the, actually it's gonna be even more interesting. So source path, but what if we use the same name, right? Binary path. Yeah, that's actually very interesting. So we can preserve the name. Okay, and the next thing we can do in here, then we can just execute the binary path. Yep. That is actually very interesting. So you basically rebuild itself, then you run yourself, and since your own time is going to be greater than, greater or equal than source, it's not going to go into recursion. It may potentially go, but reproducing such conditions, I just don't see how to reproduce them. And anyway, so let's just try to rebuild this thing, right? No build.c, and if I try to run no build, everything is up to date, right? Everything is up to date. But now I'm gonna try to put something in here, right? So hello, right? And I'm not gonna rebuild myself. I'm only gonna run this thing. Okay, that was very interesting. So the first thing it did, it rebuilt itself, right? Then it ran itself, and then said hello. If I try to run it one more time, it didn't rebuild itself. Stream is over. Gia, you know that stream is not over. Because all that approach works on only on POSIX systems. Yeah, this entire approach works on the POSIX system. So one of the systems is going to be a shit show. Right, because what it basically does effectively, right, if you look at what precisely it does, the program straight up modifies its own binary while it's running, which is totally fine on Linux because, like, I suppose the image is sort of like loaded into memory, cached, and that's it. You can modify that file however you want. And it's not going to affect the currently running program. But on Windows, as far as I know, while the program is running, you are not allowed to modify its binary file. The binary file gets sort of locked, if you know what I'm talking about. So on Windows, you'll have to do these weird tricks of, yeah, Gio already tried to implement something like that, yeah. You have to do like weird tricks of like staging the restart with several processes or something like that. So we can try to explore that. Or we can wrap this into a cross-platform interface and just crash on Windows and say it's not implemented on Windows yet and address that later. I don't know what I'm gonna do right now, so it's kind of interesting. So implement it later. But it would be nice to actually support that on Windows. And as far as I know, Gia actually solved that on Windows, and I'm kind of contemplating, do I want to steal your solution? Because Gia actually implemented a similar tool, but using C++, right? Steal my code. Okay, so maybe I can steal your code. Let me try to find. I don't remember the name of your repository. So Nabs. Okay, so it was Nabs. Yeah, I do remember that. Yeah. It's that one. Okay. Is it okay if I put your repo in the description? Right. Nabs. Okay, so for people who's interested, so because it's a part of the references, right? Because I'm referencing the solution, and let me take a look at how it's implemented on Windows. On POSIX, it's super easy, but yeah. So I'm gonna assume that's a lot of code. It's still loading. That's a pretty powerful build system, not gonna lie. Alright, so rebuild. Is anything... Okay, automatic compilation. Okay. Usage and rebuilding of precompiled headers. Maybe it's not what it is. Self-rebuild. Okay. So let's search for self-rebuild. Okay, thank you so much. That was the build. Okay, it's actually similar, right? You also look into the arguments and this current source file. Okay, that makes sense. Self-update. This is only a declaration, right? So we need to find the definition. Okay, so on Windows, we get temporary file. We don't care if these files, we don't want to throw exception. Okay. So it looks like you have a more complicated situation, right? First, get modification time of this file. If it needs rebuild self. Okay, so there's another layer of indirection in here. Okay, so rebuild self find CPP compiler. Okay. So different flags. Okay, this is basically where the rubber meets the road. So new name, sorry for, it's all right. So it's actually, I've seen worse. You cannot surprise me by messy code because I've seen some shit. Don't worry about it. All right, so this is the file where the water meets the kettle. So you compile the files, right? Replace self Windows. This one is interesting. On Windows, of course, this is a massive fucking pain. Yep. Yep. For POSIX is just exactly. It's like literally what we do right now. This is literally what we did in here. It's just like a rename. We don't even have to rename. I can just literally compile it into the new file. But this one, so this is the magic function. Replace self windows. All right, let's take a look at it. Okay. Before we do anything, rename ourselves to something else. Replace file. Create process. Wait for the child process to finish. And rename the incoming one to our old name. Not sure if I fully understand this thing. All right, so we're compiling new version. So we need to understand like a more straightforward scheme. It's no build, delete me, then new no build, no build. Okay. All right. So let me see. And then the thing looks for delete me, I suppose. Right. Okay, so if no build, right. So it is running, so it is currently running. The thing it does, it creates new no build, new no, it's no build, new no build. There we go. And then I suppose it runs new no build, right? I suppose it runs new no build, right? So after it created it instantly runs it. So we have two things running in parallel. Do I understand that correctly? So there's that and that. At least I'm basically outlining how I would do that. Interestingly, because you can, if you rename yourself into delete me, you cannot do that because you're currently running. You need to essentially exit somewhere at some point. Right. Okay, this one is rather interesting. Okay, how I would do that? You can rename it while it's running. But you won't be able to do it. Okay, so here's how I see that. Then we create a new process, then oh, this one is interesting. Okay, so I can rename it while it's running. So that means the first thing I want to do is rename myself. I'm renaming myself like so to delete me, right? To delete me. Then I start a new process. I start a new process with the name. I'm create and start it. New build.exe. New build.exe. Right. And new build.exe, new no build, whatever, is supposed to delete me. But I can't delete me until I actually terminated that process. So that means for new build to delete me, I have to instantly exit somewhere here, so later new build can delete me. Do I understand the situation correctly? So you run this thing and you instantly quit, so you unlock the file and then it deletes itself. In theory, yes, but in practice does it work? In practice it should work. I had issues separating the child from the parent. Oh, okay. That sounds actually very funny out of the context. Had issues separating the child from... So the old one waits for the new one to finish. Then both die together. Interesting. Okay. So that means sad story. It is in fact very, very sad. So it means new build, but new build can actually detect that there is delete me and it can change its state accordingly, right? So the question is, if they die together, okay, new build can rename itself, right? New build can rename itself, so it basically rename itself to basically this. No build.exe. So we just renamed ourselves. Go rename yourself. All right. So then we just let them be, and they die together. The question is, who's deleting delete me then? I suppose delete me should be deleted on the next no build run. Right, on the next no build run, if we didn't detect that the rebuild needed and delete me exists, we deleted it. So there is like this trade-off. There is a little bit of garbage left from the update, but at least you can replace it on Windows. So this is literally your approach. So I understood your approach correctly. This is actually a pretty good approach, actually. I like it. It would be kind of nice to get rid of the delete me. Maybe it is possible to many days of molding. Yeah, thank you so much. Thank you so much for many days of molding, because yeah, so you basically gave this approach to me, so you suffer it for me, right? Because now I can just go ahead and implement this approach without like suffering that much. So I really appreciate it. Thank you so much. Like genuinely, thank you. Outsourced molding, yeah. You can separate child from it, but you can run into a race yeah. So I was also thinking about that. You can try to do that, but again, it's going to be some sort of a race condition. It's better just to do that. The question is, can you can rename your file, but can you move it? You know what I'm talking about? Because isn't moving a file essentially renaming it? Right, you're not modifying the file, you're just changing its meta information, right? Because the actual path location of the file is basically its meta information. You can move file to rename files and so on. This is actually quite good. What if we, instead of calling it delete me, we move it to temp files? Just move it to temp files and never delete it and just forget about it. You know what I'm talking about? Just move it out of the way to the place where it just doesn't matter. So you see, together we came up with a pretty cool solution. So you came up with the first part of the solution, I came up with the second one. So perfect. So, and that actually simplifies everything. You just move yourself out of the way and you don't have to delete anything. It's just like, and temporary files, depending on the configuration of the system, they're going to be deleted after some time, right? So I don't quite remember how it works, but I'm not really good at system administration. Yeah. All right. So yeah, that's pretty interesting. So there's a new build, a rename, and so on and so forth. Okay, that's pretty pogue, not gonna lie. That's pretty pogue. Thank you so much for the solution. Alrighty. How are we going to be approaching all of that? I wonder. So in POSIX, it should be relatively easy to rename yourself, right? Go rename yourself. I want to try that, by the way. Foo.c. stdio stdlib.h. I'm just thinking maybe I'm gonna implement this kind of solution for all of the systems, right? So maybe even on POSIX we're gonna do it like that, just in case, right? So it's just like on it's simply on different operating system it's gonna perform different calls, right? So on Linux is going to be some syscall, I think it's a MV syscall maybe, I don't know. And on Windows is going to be WinAPI calls. So yeah, we'll see how it goes. C creates a new process which runs independently. This is not really the problem we are solving as far as I know, right? Sounds like you can terminate parent without affecting the child. But if we're gonna move the delete me out of the way, it's irrelevant. So I don't know. Linux C rename file. I forgot how we do that. Oh, there is literally rename apparently. Oh, I so got used to POSIX bullshit that I would never fucking assume that the function that renames files is literally called rename and accepts the old name and the new name. What the fuck? Alright, so, okay. Didn't expect that, but sure. So we're gonna assert argc equal greater than 0. And this one is going to be rename. Wait a second. stdio? Is that a part of the C standard or something? What the hell? I can't believe. No, it cannot be a part of the C standard. That's for sure. It must be POSIX. It must be POSIX. POSIX mate. Okay, so the old one is gonna be argv0, and we're gonna rename it to something like, I don't know. So we can have some sort of like a buffer. So it's gonna be malloc, essentially strlen of argv0, right? Plus, let's put like 10 in there, right? So this is going to be the buffer we want to put in here. Might as well have something like buffer cap, so that this is the buffer capacity, right? And I'm going to put it in here. Buffer cap, and it's going to be Sn print capacity. Sn Printf buffer cap, and it's essentially going to be something like kappa, right? And in here we're going to have argv0. So every time you call the program, it renames itself by appending kappa.kappa at the end. What is Sn Printf? I don't know. Let's ask the magic cube. Sn Printf. Composes a string with the same text that would be printed if format was used on printf. But instead of being printed, the content is stored as a C string in the buffer pointed by C, taking n as a maximum buffer capacity to fill. That's your answer. $5, please. Anyway, so I don't know what kind of answer did you expect. -5 will double you, yeah, exactly. Okay, so this is the old one and this is the new one. Okay, so if I rebuild this thing, foo.c. Okay, so this is the assert. I need to include assert.h and string.h. Oh, right. You thought my Googling services are free? No, 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 no. You know, Googling all day is a hard job, okay? So it needs to be compensated. So there we go. So we have executable, and if I try to run this executable, it just got renamed itself, right? If I try to run it one more time, it does not exist anymore. So it's an executable that constantly tries to escape from you. You run it and it disappears. Holy shit, this is such a cool idea. I need to create a I need to create a program that every time you run it, it moves itself to a random position in your home folder. And here's the rules of the game. Every time you find that executable, you have to run it. And so it moves into a different, completely random position again. And this is so cool. Capture the playable program runs away from me. Yes, we need to do something like that. Perfect. Oh, I love it. Programming version. I love this. You can turn it into a virus and essentially clone yourself and just put it in the random position, random places and stuff like that. But I mean, I don't really like to do anything malicious. But that sounds like a pretty interesting idea. So the question is, how do you choose a random position? I suppose you start traversing from the home, and every time you recursively traversing, you pick a random folder, and also with the probability of 50%, you either stop or not at a particular folder, and then this is the place where you can go, right? So something like that. So basically you just traverse in the tree, but you traverse in tree in random directions and stop at a random time. So that's how you can do that essentially. Sounds like a pretty cool idea. Somebody should probably implement it. And again, so if I try to run this entire thing, every time I run it, it basically adds .kappa to its name, right? It just adds .kappa, and the second time it does not exist anymore, right? So there we go. We need to implement a rename function that works both on POSIX and Windows. Right, in Windows it's going to be implemented in terms of move file ex and stuff like that. Quine. This is not really a Quine. I think you're misunderstanding what is a Quine. Kawain desu. All right. So we can move ourselves. And where we can move ourselves? Can we move ourselves into foo? Into temp, right? So the thing I can do now, right? I can do this, and well, I still need the buffer. So, and inside of the buffer, I'm gonna just put. Well, the thing about this stuff is that the program name can have several components, right? So it means we need to have something like base name, right? We need to have something like base name, right? And in the base name, base name probably returns something that you have to free. Do not pass these pointers to free because they're probably in a local static memory. Okay. So TMP base name, right? So it can be base name, and then maybe I can actually do something like printf s to s, where we're gonna do argv 0 buffer, right? And then we're gonna be moving ourselves there. So I'm gonna remove this entire thing, and it's gonna just see foo c, Base name does not exist. Well, I mean, it just has implicit declaration. So implicit declaration of our nation is not particularly acceptable, I think. So we're gonna put this thing in here. Yesu, kawaii freaking desu. And now, if I try to run this entire thing, it says move foo into TMP. And it didn't work. Oh. Probably because it didn't move anything. So rename probably only renames the... Okay, so that's kind of interesting. I think what I need to do in here, I need to check the result of this thing. std error, could not rename file s to s because of s. And in here we do argv 0 buffer str error no, and then we're gonna just exit with 1 s to s exactly. Could not do that, fortunately. All right. So let's see. Could not rename invalid cross-device link. Cool. That is very interesting. Linux C move file. How do you move the file? Move the file on Linux and C. So the usual way to move a file in C is to use rename, which sometimes fail. If you can't use rename syscall, you have to query the size permission and other metadata of the... Why would it fail? Rename has to be atomic. Ooh, I see. The original and new location of the file, same move, is conceptually identical to rename. But why it wouldn't work? I have a weird suspicion that something is sus. Yeah, I can create files in there. I do have a permission, but I can't move this thing. Could not rename file to invalid cross-device link. Okay, so let me see. Rename invalid cross-device link. Is temp some? I think so. If your source and destination are the same file system. Oh, okay, that makes sense. So wait a second. Where is TMP? Oh, I don't think so. Maybe TMP FS. So maybe it's OSBLK? No. Oh. So maybe I should use these ones. Echo TMP. What's the variable for temp folder? I forgot. TMP dir. Linux find TMP dir. I forgot what it is. Get temp path. TMP dir is more standard. Both it's temp. Okay, so there's at least temp and also temp. None of them actually show me anything. All right, so C find TMP folder. There should be something for that. How to get a system folder in C++. Boost. Of course. Okay, what the hell is that? Okay. Where's the temporary directory on Linux? Well, I mean, we can try to do something like TMP dir. Printf TMP dir s get env TMP dir. Maybe in that case it will work. Right. And it was null, so I literally don't have TMP dir. Neither do I have temp. Neither do I have TMP. so I literally don't have them. So I quite remember there was a way to do that, but so on Windows it's relatively easy, just get temp path and that's it. But on Linux, maybe I'm gonna put Linux in here. Make TMP sounds like a plan. Okay, create a temporary file or directory. Oh, it's actually data command. Make temp 3. Okay. Make a unique temporary file. Sounds good enough. I guess we can do that. So what does it return? It returns a character. Okay, thank you. Temp file make temp no build. Description, never use this function. See bugs. Oh my god. Some implementation follow replaced by make dtemp. Okay, so we can try to look at this thing. Make stemp. Generates a unique temporary file from template, creates an open file and returns open. Okay, I don't think this kind of like thing is really important right now. We just want to get something that is working. Okay. So wow. It is very dangerous, apparently. They not only say that in the documentation, but if you try to link it. If you try to... Wait, is it really linkage? So this must be a very dangerous function. Must be a very dangerous function. Oh my god, okay, so I never thought I'm gonna encounter such a... Well, what's funny is that gets... Do we have gets? If I try to use something like gets, will it also complain about that? So look, I have a buffer, right? So when I do gets buffer, will it also complain about this function the same way? Well, okay, so it also complains about gets. That's pretty cool. That's a pretty interesting way to warn people about like dangerous functions and shit. Very, very interesting. All right. So we have to do mkey stemp. Okay. So if I try to foo, and it actually segfaults. I wonder why. And where exactly it segfaults? So I'm gonna actually remove these things, right? I'm gonna actually remove these things. And it literally just segfaults. Nice, thank you very much. Okay. So let's go to no build. Where is the function? Oh, where is home? Right. So let's actually go there, and might as well, you know, build this stuff with GDB. Right, and then GDB foo run, and I want to see where it fails. Ooh, am I an idiot? What does it return? It returns some freaking integer. What the hell is this shit? I just want a file path. Okay, generates a unique temporary file from opens the... Oh, fuck's sake. No, it's 2 hours timeout to this person, please. Okay. Make temp. Thank you so much. But I only wanna... This is annoying. This is really annoying. So, and what's funny is that I just wanna find the folder where I can move my shit. You know what? Does it open it? How does it work? Generates a unique temporary file, creates and opens the file and returns open file descriptor for the file. Okay, one of the things we can do is essentially close the file, right? Maybe before we close the file, we can try to do fstat, right? And get its name. So as far as I know, stat buff should contain its name, right? Does it have a name? Or path? Or any way? This is really annoying. I think we need to make a small break. Alright, I made an executive decision. We're not gonna do temp file thing yet. Right, so we're gonna put it on a back burner, right? So I'm gonna create a separate issue to implement the temp file sort of escape, right? But for now, we're gonna follow the JS solution, essentially renaming ourselves into delete me, and then, you know, deleting it later. Maybe we're not gonna even delete it. Maybe we're gonna just like let it be for now. But we'll see how it goes. Because right now, like the entire thing with temp files looks more complicated than it should have been. It's really unreliable to get the location of the temp folder on POSIX, and sometimes moving it's kind of difficult, right? Rename doesn't work. Let's just not do that at all, right? So let's just like let it be. Okay. So in CEO, yeah. So I have to make a lot of executive decisions all the time, so it is what it is. All right, what we know for sure is that we can easily rename ourselves within the same folder, right? So we can do at least that, which is nice. So where is my diagram? Right, so I rename myself, then I create the same thing and I run the same thing. Okay, so that should be actually pretty straightforward. So no build. Where is no build.c? Here it is. So the first thing we can try to do, rename, right? We definitely will need to have this sort of cross-platform macro in the no build. So we're going to be renaming binary path to delete me, right? So literally to delete me, and then we're going to be rebuilding this entire thing. So binary path source, and it actually heavily depends whether it's MSVC or not MSVC. But for now, we're gonna just keep it like that, right? And in no build itself, we definitely don't have a rename, but something like make dears. All right, path make dears. Path make dears. Okay, so where is the declaration of this thing? I want to do the following thing. Path rename. Path rename. This one is kind of interesting. Do I actually apply the formatting to my no build header in the original repo? I don't quite remember actually. So if I take a no build, do I have any changes in here? It takes some time for some reason, but okay. And then I go to the no build and I refresh everything. Everything seems to be Okay, okay, so I do format it. Okay, so I won't accidentally break the entire file if I reformat everything. All right, so no build demo. So what I want to have in here is a sister old path, sister new path, right? So, and then we're going to have a following macro: rename old path, new path, right? Old path, new path, and in here we're gonna inject some sort of a logging. 1, 2, 3, 4, while 0. Okay. So we're just gonna call to path rename old path new path, and in here we're gonna do a log rename this to this old path new path. So essentially these macros are intended to constantly trace and log every like each individual action for the convenience of the user, right? Because it's quite convenient when each action is actually logged and you can clearly see what's going on in the build system. So I actually quite like it personally. I don't know what my neighbors are doing right now, but they're doing something weird. So wait a second, did I just... Yeah, that thing. They're doing that thing. Okay, so if we are on Windows, Win32, we're gonna panic. Well, if I were using Windows, I would be panicking. I would be panicking Skywalker. Oh, I'm sorry. To be fair, sometimes I do want to have like a stable Windows setup so I can play video games. Computer games, actually. Not. Well, what's the difference between video games and computer games? I guess it's the same thing. I think video game is like a very old term from the times when you plug in things into your TV. That's why they were video games, like into the video input. If you know what I'm talking about. That's where I think the term video game comes from. I don't know. So a panic, right? Rename is not okay. Rename is not implemented on Windows on Win32 yet, right? So and this is going to be a separate to do. As for this thing, we're going to be using rename old path and new path, and if this entire thing is negative, right? We're gonna be panicking yet again. Could not rename this to this because this old path, new path, and str error no. There we go. So that's pretty straightforward. So we have a rename. No build.c. Okay, so first thing we do, we rename this thing to delete me, and then we compile this entire thing, and then we just run this entire thing, and then we die together. Right, then we die together. And I guess that is basically it. So if I do gcc, as far as I know, I can even do something like this. Does not even compile. Oh shit. I'm sorry. So maybe I can do even something like this. 1, 2, 3, 4. And in here, sort of what? Okay. Align. Align rejects. Okay, cool. All right, up to date. So it actually printed hello, but that was okay. Seems to be working, and now if I try to modify something, what if I remove up to date completely and then I just run no build? Okay. Oh, this one is interesting. So it actually printed hello twice. So for this to work properly, I think we need to always do that at the top. And furthermore, I think we also should exit with 0, right? So yeah, source. Oh, and yeah, this kind of stuff has to be also at the top. Right. So this is a chunk of code responsible for rebuilding yourself. Right. Okay, and well, it tried to do. Okay, so. It tried to do the thing. Let me try to do it one more time. I could probably maybe move delete me back to no build, right? And just try to run it yet again. And it kind of did work. But for the second time, yeah, it is working. Right, and now if I go to no build.c and I just change it to hello world, yeah, it rebuilt itself. All right. And I also like that it also reports what it's doing. Right, it also reports what it's doing. So it renamed itself into delete me, then that, and then that. Furthermore, we can do the following thing. If, how do we check that? No build, no build. Exists. Path exists. Okay, if path exists, delete me, right? RM. Well, to be fair, you can always try to remove delete me. Well, then it will report something, so let's not do that. Delete me. Okay, so if I try to do that, ooh, that worked actually quite well, I think. Well, yeah. It may not work on Windows because you will try to delete... You know, I have an idea, actually. I have a genius idea. Oh my god. Look. You rename binary to concat binary path old. And now, this is not a bug, it's a feature. We preserve the previous version just in case something goes wrong and we never have to delete it. Yes! Turning bugs into feature. This is a feature now. Yeah, we preserve in the previous version. Yeah, there we go. So, and that simplifies everything. Yeah, it's a part of the use case. So if something goes wrong, you can always go back, rename old into the current one and try again. Perfect. More files to get ignored. All right. So that's cool. And it actually did a weird thing. So it kind of rebuilt itself. Hello, chat. And yeah, no build old. No build old. Alright, so that's kind of cool. Oh, you know what's even cooler? If you try to call no build old, it will rename itself into no build old. And you can actually go deeper, and now we have no build old, and it keeps basically backing up itself. This is genius. I love that. Why do I have so much fun doing this shit? I don't know. It's kind of fun. Alright. Alright, so that's pretty cool. So we have that. Hello, chat. And maybe the next thing we want to do cmd ccl main main.c, right? So, and now I don't even have to rebuild the main thing. It just rebuilt itself, and now it built the main, and there we go. That's freaking perfect. No build.c, right? And if you rename this to hello, right, and you run no build, okay, so that's pretty cool. And essentially now you can sort of take I guess this entire chunk of code, right, and wrap it into a macro, right? Something like rebuild yourself. Go rebuild yourself. You have to provide argv and argc. So, and then we're gonna be taking this entire thing and we're gonna be just putting it in here. And query replace. Actually, I want to query replace with the regular expressions like this. It didn't work, really? Why didn't you work? Okay, and then I can go back and basically align rejects with this thing. There we go. And now we just can have this kind of thing. Go rebuild yourself. argv, arg. Well, first one has to be argc, I think, and the second one has to be argv, and because of that, we'll have to swap them around. Like this. There we go. So this is a macro, and it's going to abstract away the entire process for you, right? So what you have to do, you just have to put this in here, and it will always try to go and rebuild itself. So, and now we can basically hide away this entire thing. So, and also this thing has to be implemented for Windows separately, right? And also on, I guess on different operating systems, it has to be also implemented differently. So that's a very interesting thing. Go rebuild itself. Surprisingly, maybe it doesn't even have to be a macro. It could be just a function by itself. Like, I don't see any problem with that. Okay, so maybe what we want to do in here, we want to make this a cross-platform function. Modification time. How do you get modification time on Windows? Win API. WinPay get file modification time. Get file time. So there is a get file time. Retrieves the date and time that the file objective was created, last accessed, and last modified. Okay. So access creation, right? So we were gonna care about this thing. So, and we have something called LP file time, right? So this is LP file time. And what is LP file time? So LP stands for like a long pointer, right? So file time contains 64-bit value represented the number of 100 second since January. So Windows Epoch is slightly different. Which is rather interesting, but okay. Oh, by the way, maybe WinAPI has a stat thingy. WinAPI stat. Yeah, it does have it. Okay, so because it has a POSIX layer. All right, that's cool. So, and it has a structure and whatnot. Yeah, so in that same structure, struct stat. Okay, what's the definition of a struct stat? Are you gonna show me the definition of a struct stat? I think I'm blind. So I wish there was a way to just click on it, but I don't see it because I'm a dummy. Return value. So equivalent, stat is equivalent to end contains 64-bit time. God damn it. Struct stat win API. Finally. Wait. stmod field. Where can I just find the... What? Stat structure. Finally! Holy fucking shit. Okay. Well, no. I give up. This is horrible documentation. Okay. last modified time, and it's going to be in amount of seconds or something. It does not necessarily has to be like a Unix timestamp, right? It's just like in seconds. It's something comparable, right? It must be something comparable. Yeah, it could be, we can call it like a time, right? So, and on different platforms, maybe it's going to be a different thing, who knows? Maybe not. Okay. No build.h. Path. Path last modified time. And here we're gonna accept the path itself, right? So then path rm, where is it implemented? We're gonna put it in here. And let me just put this thing in here. Path last modified time. If we are on Windows 32, we're gonna say panic to do is not implemented on Windows yet. So, and I'm thinking that I'm gonna do something like this. The result, maybe not. So maybe it has to be like a part of the documentation, right? The result of the function is implementation defined. The only thing that is required from it is being comparable, right? Comparable. So we can easily check when a particular file, if a particular file was modified before or after another one. Does it make any sense? The result of the function is implementation defined. The only thing that is required from it is being comparable, so we could easily check if a particular file was modified before or after another. This is a really weird wording. A particular file was modified before. Does it sound all right? So we could easily check if a particular file was modified before, after. Okay, I don't speak English, I'm sorry. Alright, so and in here we're gonna be doing and if. Right. So this thing is not implemented on Windows, but it is implemented on POSIX, and this is precisely what we can use in here. Yeah, path last modified time. Okay, so it's almost cross-platform already. It is almost cross-platform, except this thing. Except this thing. So, and what I'm thinking is that maybe we could actually extract it to a separate function. Rebuild yourself. Rebuild yourself. And here we're going to accept binary path, right? So accepting binary path. And const char source path. There we go. So if this entire thing is Win32, right? If it's Win32, we're gonna say this thing is not implemented yet. So rebuild yourself is not implemented on Windows yet. Otherwise, we're gonna be just doing this thing. Right. And if. So, and in here, we just do rebuild yourself. Binary path, source path. Okay, so we have that at least. So then I'm gonna do align this thing like that, and no build.h. Right, so where are we gonna put that? I don't know. I'm not even sure if calling it yourself like that is a good idea. I think that's fine. So where are we gonna put all of this? Where are we gonna put all of this? So this is CMD array. Some other stuff, chain build from tokens, path exists. I'm gonna put it somewhere here because I don't know. Path is dir, and the implementation will go here. So here is the implementation, and does it make any sense to make it a macro? There's like literally no reason to make it a macro. And if you're gonna make it a macro, you might as well actually get rid of the arguments, right? So, and the only place where you can place this entire thing is somewhere here, right? So, yeah. That sounds all right, I suppose. Oh, and another interesting thing. What if you always rebuild yourself? So the point of bootstrapping is that it's fast and easy, isn't it? Well, it actually depends. Align something like this. Align rejects. So I'm gonna put no build.h in here. Go rebuild yourself, and this one is gonna be a macro. So, and the idea is gonna be you just put this macro here in the main, and the thing is going to basically rebuild itself when it's modified. So source passing to arguments makes from a pointer. So source path, yeah, it's supposed to be path. Okay. Alright, and what's fun is that demo. So if I modify it, and it's segfaulted. I wonder why it's segfaulted, excuse me? Oh, and by the way, this is where it comes to play. So I can rename it back and try again. So yeah, it's segfaulted on trying to rename things. Is that because I didn't properly check it? Path rename, old path. Yeah. No, it was actually fine. Alright, so I'm gonna rename it back, and I guess I need to gcc no build.c, but I want to actually build it with ggdb. Right, and what we're gonna do in here is debug this thing. No build, run, and where did it fail? Okay, so it's fine. It was apparently fine. I don't know what happened, but apparently it was totally fine. Oh, okay. And it's totally fine again. I hate it. Well, now it works. Of course. Yeah. Now it works all of a sudden, of course. And then... Alright, so that's fine, I guess, more or less. So in no build .h, we have a bunch of to-dos, right? So go rebuild itself, rename is not implemented, and path last modify is not implemented. So we need to implement these three things on Windows, right? So I guess on Windows we could just put CL in here, but it actually heavily depends on what you want to like use. Are you using min.gw or are you using min.gw or using MSVC or something else? So you changed the outcome by measuring it. Yeah. So that's basically what happened. Okay, so I think that's pretty much what I wanted to implement in here. So let's actually try to integrate it with the main no build repo. So and see. We definitely need to test that on Windows, but again, we need to implement all these functions. Okay, so maybe I'm gonna just go ahead and steal some stuff from GS source code. So I'm gonna click on your nickname and I'm gonna find the source code. There we go. Inspection time. This part is gonna be some if dev soup. Yeah, that's for sure. Move file ex. You know what? I think I'm gonna just simply download this file. Holy fucking shit. It's so slow. Alright, GitHub is extremely slow. Alright, so I'm gonna just download locally so I can search it. My Emacs is faster than GitHub, by the way. So, move file ex. There we go. Replace self Windows. Okay, move file ex function. Функция. This is how Russians say function. Функция. Oh no, it's функция. Okay, so there is a T in there, right? So in the middle somewhere. Okay, finally it loaded up. Existing file, new file. Okay. Russian Spepelov. Rename. So, and path rename. So this is what we can do. I'm literally copy pasting your code, by the way. I'm so sorry. So that one was existing file, so that means it's an old one. Right, it's an old one. Old path, and this one is new path. Move file, replace, and if it's bad, right, I think for Windows we have a special thing, get last get last error as string. So that's how we do that. Of course I'm gonna credit her, that's without any doubt. Alright. Path rename. So, and in here, this is how we do that. Panic. Could not rename S to S because of S. Yep. Maybe I could actually abstract away these things, so on POSIX it would use str error, and here it will use get last error a string or something, I don't know. So old path, it's almost as we both got get lost. Yes, yes. I can't even know from which place you got it. I think it was some sort of old like Stack Overflow post. Yeah. So. Ooh. And that's why GitHub Copilot is a thing, because essentially GitHub Copilot automates that, right? So yeah. Yeah. 2021 development is beautiful. Oh, you also used. Wait a second. Did I actually credit the place from which I stole that? Oh yeah, I did actually. I forgot about it. Yeah. Okay. So I wonder how many times this specific piece of code was copy-pasted from the internet. Yeah. Will you try Copilot in the stream? Is it open yet? Can you download? Can you download it already? Or is it like, you know, closed beta or something? I don't know. You can sign up. How often do you use Visual Studio Code? Rarely. Okay. Is that it? Well, since I'm logged in, maybe they can look at my profile and see that maybe they want to give the access to this guy. I don't know. We'll see. Young telemetry. Yeah, I suppose. Because I can try to do that on a stream or something. What was doing? I was renaming files. Path rename. Okay. So move file replace existing, could not rename. This one is implemented, in fact. All right. I'm just changing the style so it's not completely stolen, right? So I'm stealing your homework, but I'm changing it a little bit so it doesn't look the same, you know. Okay, so we changed that, so it's gonna be to do. Rebuild itself. Okay, last modified. Get. Okay, I forgot what was the function. Did you just use stat? I wonder. No, you didn't use stat. Windows get modify date. I forgot the name of the function. It's actually not Windows, it's a Win API. Oh, you used... okay. Oh my god. I'll have to... we can just do get file time then. A pointer to file type structure, file time structure, and from the file time structure, long date, low date time, and high date time. Contains 64-bit value representing a number of 100 nanoseconds intervals since January that. And how are you supposed to use this shit, excuse me? To convert a structure into a time that is easy to display for user, use file to system time. And what does it give us? File time, LP system time, and LP system time is a system time, which is this shit. But to be fair, I just want to compare things. If it is not recommended that you add a subtract values from the file time to obtain relative times. Instead, you should copy the low and high order parts of the file time to U large integer structure. Perform U64 arithmetics on quad part member and copy the low. Holy fucking shit. I guess it's to prevent like these, you know, bugs in the future when the time overflows or something, right? So it's a goddamn maze, yeah. Amazing maze. All right. So set file time. I don't even know where to start. Okay, win API compare. Win API compare file time. So you can combine the two D words into E64 and just compare them. Oh, we have a compare file time. Okay, and it accepts the pointers. That's POUG, and it returns. Okay, so it's a basically CMP function. Perfect. Yeah. That means we cannot use like a less. We cannot use less. That means we need to have a separate function for this kind of stuff. All right, so I think I'm gonna leave it for the next time because I'm already streaming like for 2 hours. So I think it's still gonna be a separate. Well, we need to modify it accordingly, I think. So I think there's supposed to be a function something like. Do we even use booleans here? We don't use boolean. Well, I mean, in the Win API we do use them. Is file modified before? Is modified. So go rebuild yourself. So this thing. Modified after. Okay. Vlog function, yeah. This file is younger than this one. Is file is modified this. Path is modified after. This is actually very strange. Is path 1 modified after path 2? Is that a good function? Is path 1 modified after path 2? Path 1, path 2. Good enough. So because of that, we'll have to encapsulate this kind of stuff in here. Right. So it has to be something like this. And for Windows, it's going to be completely different, right? Because you have to compare it differently. Stat path. So this is going to be path 1. All right, and we store path 1 time stat buff. What was that? st something something stm time, right? Then we'll have to do that the second time. And so if we could do is file modified before. Oh, this is actually pretty cool. Oh my god, this is pretty useful. Right, so you don't have to come up with this kind of like weird names. Yeah. Nice. Well, I mean, named arguments is, I think, a must-have feature in modern languages, right? Because they allow you to do this like small DSLs. But unfortunately, we're programming in a very old-ass language. Is what it is. People think that I like C. I actually absolutely hate it. It's just like, in its category, it's really irreplaceable, and that pisses me off. Right. So, but some people may argue that, but we have C++, we have Rust, but they're not in the same category. C is not in the same category as C++ and Rust. C++ and Rust are way more complicated than C. So the category of C is low-level language, but on top of that, simple low-level language, right? So there is no competitor for C in a category of simple low-level languages. So the same simplicity only I've seen in Go, but again, it's not as low level as C, right? It is not as low level as C, so there's literally no competitor. There was competitor at some point in time, and that competitor is Pascal, and it's completely lost the war to C, unfortunately. But yeah. Then still can't, yeah, exactly. So one person can write a C compiler, but hundreds cannot write a C++ compiler. Why did Pascal die? I don't know. So the only thing I can assume is that C is more of an American thing, and Pascal is pretty much a European thing, all right? And I suppose Silicon Valley is more influential than Europeans, so that's probably the reason. But it's actually very like high level, you know, reason. I'm not sure. Maybe there's something more specific. We need a Pascal revival. Well, from time to time, I secretly code in Pascal, specifically in free Pascal, and I really fucking enjoy it. But I code specifically in the original dialect of Pascal. So without any extensions, with OP and shit like that. The original dialect of Pascal is actually quite nice. I really like it. It's super close to C, but it lacks the a lot of modern features. I suppose the closest competitor, the actual closest competitor to C is going to be Jai, right? Because it seems to be like a language that is as low level as C, and in terms of complexity, it is as simple as C, but it has a lot of nice modern features, right? That can elevate the language to the new level. Like metaprogramming and, compile time types and whatnot and stuff like that. We'll see. What about the beautiful x86-64 assembly language? Well, the problem with x86-64 assembly language is that it works only on x86-64. So that's the main problem. And believe it or not, the same problem exists in ARM assembly. The problem of ARM assembly is that it only works on ARM. And the same problem exists with MIPS assembly. And guess what? It can only work on MIPS. Yeah. That's kind of the problem with these languages. They're not portable. It is what it is. Anyway, so... When I see we just write the Scout PDP-11 code. Yeah, exactly. Wasn't C originally developed for PDP-10? Or was it for PDP-11? I don't really know. I don't really remember. It was too long ago. I already don't remember how it was. So here we have a path name. I'm not old enough to know. Well, yeah. And I'm too old to remember, right? So path 1. So this one. We should ask Dennis, I think. Dennis must know. So Dennis is so old school. He said that, you know how old school developers brag that they programmed in punch cards? Well, Dennis is so old school, he was programming before punch cards. He said that he was programming the the circuits where you have to do the manual wiring, the thing that was before the punch cards were invented. So, yeah, yeah, he's that old school. All right. Curious with that for sure. Yeah, truly. I think we even watched a video about that, right? A video about these circuits, right? So each circuit was basically a single program, right? You would wire a single program right? And then you put it into computer, and then you put it on a shelf for later usage, right? So it's a single huge board with a lot of wires. It's a single program that you load into computer. We need a video about Dennis programming. Do you know about Antikythera mechanism? No, never heard about it. PDP-10 was the system C began transitioning from B, but it was the PDP-11 that C... Oh, okay, so PDP-10 is more of like a B thing. Okay, and C is for PDP-11. All right, interesting. All right, so is path 1 modified after path 2? So path 1 time is greater path 2 time. The 2 time! Okay, the 2 timer. Okay, so this is what we need in here. And if defined win32, we're gonna do one thing, otherwise we're gonna do another thing. And if, there we go. And on Windows we have to do this stuff. So first we need this function, right? Second we need this function, creation. Can I actually set them to null? This parameter can be null if application doesn't require, can be null, can be null. Okay, so all of them can be null actually. That's perfect. I really like that. So here's another one. So LP file time path 1 time, path 2 time. Alright, so you have to open a file! Are you freaking serious? I'm molding right now. Win API example. So opening the file is a pain in the ass because you have to open with probably specific flags or something, and I fucking hate it. Alright, so you create a file, right? But can I just open the file? How do I open the file? Open... create a file. Generic read. So open for read. Oh, that's how you do that actually. You also set the security attributes in chat. You thought you could, yeah. Open file, but win API open file. Is it gonna be different than create file? Somebody needs to time out 885 because they really think that I don't know how to Google. This is sus. I'm gonna use something that I already used before. Alright, so, and I need to open both of them. Wait! Open file for read. FD open file for read. Go time out yourself. Yeah, go time out yourself, seriously. Thank you so much for time outing yourself. I really appreciate it. Okay, so I think I can just do it like that. I do have like a cross-platform function, so which I can literally reuse. Modify it after. So this is basically what we can do. It's going to be path 1, fd path 1 fd. Alright, and then I can just put path 1 fd. So cool thing is that fd on Windows is going to be a handle, right? Type def. You better believe in my Googling skills, okay? Yeah, it is basically handle. Right. Yeah, it is handle, okay. Yeah, no believers. Creation time, last access time, last write. So we don't care about this shit. But we do care about well, by the way, this has to be just LP time. Path 1 time. One more time. We can see the brain. Okay. return value non-zero. If the function fail, return value is 0. Okay, so if not, panic. Oh, by the way, this could be actually panic. So you just panic. Panic. There we go. Could not get time of this because this path 1 get last error as string. All right, so after that we might actually fd close this entire thing, right? So it's gonna be path 1 fd, right? So fd path 2 fd open for read path 2. Might as well copy paste this thing and just query replace path 1. Path 1 path 2. There we go. Then here comes the Johnny. Path 1 pointer. Path 2. There we go. How does it work? The first time is earlier than second time. The first time is later. After, later. I think that's what we need to do, right? So the first time is later. The first time is later. That means it's modified after. All right, that looks good to me. That looks more or less good to me. So we create that. Don't see any problems in here. Okay, so we'll have to test how it builds on CI, of course. So there's another to do, and I suppose for now on Windows, right, we can just try to do something like, I don't know. I have an interesting idea, actually, in terms of rebuild yourself. Let's make it a macro. If not defined, rebuild yourself. Binary rebuild yourself. We're gonna define it for you. So essentially, you would be able to replace it however you want, right? If you are 1, 2, 3, 4. If you are on Windows, right, we're gonna basically give you the following implementation. Maybe it's gonna be something like this. Define rebuild yourself binary path, source path, and it's gonna be something with CL, right? So it's gonna be essentially cl.exe source path, but we're gonna ignore the binary path, right? So something like that. Otherwise, we're gonna define it like rebuild yourself binary path source path cmd cc o. So I don't think mandatory. I don't think it matters. Binary path source path. And if there we go. So essentially, right. If you never defined rebuild yourself, we're gonna use one of these things. On Windows, we're gonna use MSVC, and on POSIX, we're gonna use just that. If you're not happy with it, if we have a very specific case, right, what you do, you go to here, right, and right before no build, you defined your own rebuild yourself with binary path and source path, and since it's going to be defined, this entire thing is going to be illuminated, right? So that way, so you have some reasonable defaults, but you can also substitute them to something like, you know, for your own case. All right. So, and go rebuild yourself. We're gonna actually define it here, right? Go rebuild yourself, and in here, what we're doing, rebuild yourself like this. There we go. So that's basically what we're doing in here. Isn't it POG? I think it's pretty POG. So because it's not going to work in an environment where you have a min.gw, right? So you definitely want to substitute it. And as Gia said, it's definitely going to be like a macro soup, like if dev soup in the future, right? But we definitely need to support min.gw, I think, right? So it would be nice to have a min.gw in here, but I'm not sure. Yeah, so go rebuild yourself, has to be defined in here. You can, yeah, you can also detect min.gw, but I don't quite remember. Okay, so let me see. Do we have any other to-dos? I think I actually addressed all of the to-dos. Nice. That's pretty POG. That's pretty POG. Okay. Oh, okay. So thank you. Maybe I'm gonna actually add that. Rebuild yourself. But I don't know what to call it. Okay, so I'm gonna actually put it to do in here. Rebuild. Rebuild yourself does not detect. Does not distinguish MSVC and min.gw setups on Windows. So we're gonna word it this way, right? So that's how we're gonna word this entire thing. So I want to check if this entire thing works on POSIX now. And undefined reference path. Okay, that's cool. It's cool and all. No build.h. Did I rename it? Oh yeah. Okay. Yeah. We don't have that function anymore. Thank you. I completely forgot. We don't have that function anymore. So what function do we have now? Is path 1? Yeah, that's right. Dummy function declarations. Yes. So this one is going to be source path. This one is going to be binary path. So something like this. And interestingly, we don't need to do that. Well, yeah, we still do need to do an assert in here. Okay. So I also can just do something like this. Okay, so source path, binary path, then is path 1 modified after path 2. Source path is modified after this one. We rename this thing to old, rebuild yourself, cmd path, and exit. Perfect. Okay, so if I try to do that, let me try to build this. Okay, everything builds properly. And now if I modify this thing, hello, could not exec, so apparently it didn't go. Oh, I know. I just shot myself into the leg. There we go. I redefined rebuild myself, and that's why it didn't work. Thank you very much. And now, well, yeah, I have to actually start from scratch, essentially. I'm going to just see no build.c, and if I try to run this entire thing, right, so it rebuilds everything, but if I modify this entire thing, it actually rebuilds itself. Okay, that's cool. That's pretty POG. That's pretty pogue, not gonna lie. I guess that's it. So theoretically this should work on Windows. But will it work on Windows? We don't know yet. So let's go to no build original folder, right? So Zozin no build. I don't want to remove this thing, of course. Let me fetch the latest stuff. Forehead. So no build.h. Do I have to-dos? Oh shit, I have a lot of to-dos in here which I stripped off from the thing. Okay, so that means I'll have to do a little bit of work. So no build demo and do work. Yeah, as you can see, I stripped off some of the like to-dos because I didn't want the snitch to be triggered on the wrong project, so we'll have to do something like this. Okay, so we essentially remove that. Then we have to display echo. Okay, there's gonna be that. There's that. So here we have that. Luckily, it's actually pretty straightforward, so we can just remove that. So there's that, and that's pretty much it, actually. Right. So this is the whole support, actually, for both the Windows and POSIX. Okay. So let's do cco no build.c, and that's POG. If I try to run this entire thing, it is rebuilding everything and it's running everything. Dijkstra the Genius subscribed with Twitch Prime. Thank you so much for 2 months of Twitch Prime subscription, and welcome to our epic rebuild club. So what we're gonna do in here is just go rebuild yourself. Oh, this one is interesting. So it's not going to work because this thing assumes that you have argc and argv. Right, so maybe because of that the macro should accept this kind of thing. So let's do gcco no build.c, and there we go. So we don't even have this kind of thing in there. Yes. So I think we can accept argv, argc and argv. Why not? Right, so that will force the user to accept those things. And just pass them in here. Yep. And now if I try to run this entire stuff, everything seems to be working. And what if I don't want to run examples, right? So it did in fact rebuild itself, right? And now it doesn't run examples, but if I want to do something like this, now it also runs the examples. Okay, so that's pretty cool. So let's create a separate branch called, well, we also need to git ignore. So old age. Okay. Go rebuild yourself. So that's the feature. That's the name of the feature. Implement go rebuild yourself. So, and let's push that right into the repo. Git ignore. Whatever. Oh, it's Pepega. That's alright. I'm also Pepega. How do you do, fellow Pepegas? Pepegasus. Alright. I'm actually quite surprised that it was not that part. Pepegasus. Paug? Isn't that Paug? I think it's pretty Paug. Let's see if it's gonna fail on Windows. I'm pretty sure it's gonna fail on Windows. It fucking failed, mate. Alright, so let me actually close this entire shit. It's too many. About to give a job interview in like 10 minutes. Good luck. Good luck. could not rename. Interesting. Because current job sucks. Yisu, good luck. Okay. Interesting. It is interesting indeed. Huh. But it worked for you, Jay, right? So renaming straight up worked. So let me see how we do that on mobile.h. Rename. Right, so undo path. Yeah. So that's the file. Maybe I need to read more about it. Moves an existing file directory including its children with various move options. You're running this file, that's why it is not allowed. How did it work? So yeah. Existing file name, opinion. Move delay until reboot. Windows move file exe, move current executable for running exe. If the target destination is on the same volume, move file just updates the corresponding directory entries. If file empty record does not change, its index remains the same. Because the file is not affected at all, you can move it within the same directory, rename within the same volume, even if the file is in use. This is true for files being executed. In general, this is true only if the target directory is another volume. The system needs to copy it, will fail if the file is open in exclusive mode. When you select, okay. Maybe I'm using it incorrectly. So this is an old path, move file, replace existing. XZA. So do I have to use XZA because of the naming or something? But does it work on your CI though? Do you test it on CI? No CI. I see. I see. Oh, you know what else is strange? It's that it tries to rebuild itself. That's what's strange. Because why? It's not modified. Why does it try to rebuild itself? It shouldn't try to rebuild itself. So it means I could have potentially fucked up some comparison somewhere. Go rebuild yourself, right? Compare file paths. So path 1. Could be, we can try to revert it, like, because it shouldn't even trigger anything. That's the interesting thing about it. It shouldn't even do anything, but it tries to rebuild itself, meaning that yeah, the path is not correct. Compare file. Okay, let's read more about this kind of thing. Compares to file times. First file is earlier. Okay. Try to change is path because I probably do not understand how compare file time works. All right, so this one is rather interesting. Well, at some point we can just say that it maybe not gonna work on Windows, right, and create a separate issue for that. We'll see. So just waiting for macOS. Worked on Windows, which is rather sus, don't you think? Which is rather sus. So I suppose I didn't understand properly what it meant. Is the schedule correct? No. Schedule is dead. Sorry. All right. What did you change? So I suppose I misunderstood how compare file time works. But okay, so we still have no guarantee that it works properly on Windows. So I'm gonna maybe create like a to-do build.h, no build, go rebuild yourself. We need to test go rebuild yourself on a real Windows machine. Right, I'm gonna create a separate issue specifically for that, and if anyone have a time and resources after we merge this pull request, give it a try, right? So, and maybe write to the chat or to Discord, or maybe to the issue, preferably to the issue, all of your observations of whether it worked or not. The original rebuild should be done through an auxiliary copy, so the original does not get locked. Well, do you fully understand the situation that we're having? So this thing worked for Gia. So the question is, why did it work? So that's what's more interesting. Okay, so of course nobody even trying to understand the situation. I'm kind of got used to it already, so don't feel bad about it. So that's literally my day-to-day life. People completely ignoring what's going on the screen and just like voicing their opinion. All right, so a report, prepend body. That's the reason why I have to like take month breaks from time to time, just because there's too many people who just completely ignore what's going on the screen. I don't give a shit. Introduced in here. All right. So what we're gonna report? Oh, this is a wrong one. Okay, so we'll have to go to setting. No build. All right. Use. Well, we might as well actually report that one as well. Why not? Okay. we need to test. So does not render command line properly, does not render, so that's another one. Check for errors and get std. Does not render commands properly. All right, so okay, so okay, so yeah, we need to test this thing on Windows with MSVC. So if anyone have time and motivation to do that, feel free to give it a try. So after merge the entire thing. So yeah, and of course I probably need to add that to the description, right? So for people who's watching it on YouTube. Yeah, so this is the issue. Right, so we need to test. I'm gonna copy paste this entire thing, sure. And seems to be working, seems to be working. So the weird thing is that why it worked on yours machine, Gia, and why it doesn't work on the GitHub one, right? So maybe you have some sort of like a specific configuration or something, or maybe I'm doing something completely different than you, because I remember that you actually did 2 moves and I kind of skipped over that. So I'm not quite sure if I understand what you did. Move file exe and rename the incoming one to our old name. So yeah, we're directly creating a new one, so okay. Kinda sus too. Yeah, that's really strange. In any case, I'm about to merge this entire thing, and I guess I'm gonna go. So today was a really fun stream. I really enjoyed it. At least it works on POSIX, right? So, and what's interesting is that, yeah, we don't even need to remove this entire thing, like especially like the fact that there's no need to remove the old one because it's for the convenience of the user, right? So the previous build is always there, just in case you just broke completely that one. So yeah, that's pretty cool. So I can test it one more time. So here we rebuild everything, but at any point I can just, you know, remove run examples, and now this particular thing doesn't run examples anymore, right? So, and yep. Hat Pingu subscribed with tier 1 subscription. Thank you so much for the subscription, your first subscription, by the way, and welcome to our epic no build club. So alrighty, looks good to me. At least it works on Linux. If it doesn't work on Windows, we'll need to figure out what exactly is going on and why it worked with move on one machine but doesn't work on another. All right, and come up with a different solution. So, all right, I guess that's it for today. Thanks everyone who's watching right now, really appreciate it. Have a good one, and I see you next time. I don't know where, I don't know when. Check out the description if you're watching on YouTube. If you're watching on Twitch, check out the VODs channel where you can watch on YouTube offline. And I gotta go. I'm gonna go. Thanks everyone for watching. I love you all.